So it's a real pleasure for me to introduce Philippe De Ryck. He is the founder of Pragmatic Web Security, and he travels the world to train developers on web security and security engineering. He has a PhD in web security from the KU Leuven, is a Google developer expert and an Auth 0 ambassador. His goal is simple: to help developers protect companies through better web security. And we can't wait that he shares some more of his immense knowledge with us. So, if even the last people are here, and anybody still outside? Nobody wants to miss Philippe, I'm sure. So please welcome with me to the very last talk, Philippe De Ryck with his talk, Forget About OAuth 2.0. Here comes OAuth 2.1.
OAuth 2.0, 10 years old. 10 years ago, applications looked a bit differently, and surprisingly, this spec works fairly well. Well, there's a whole history between OAuth 1.0 and 2.0. I'm going to save you that story. That's something for over dinner when you have some wine to enjoy that story. But this is OAuth 2.0, and since 10 years ago, things changed. And we got some other realizations, and over time, people started adding more features to it, like additional specs covering features like OAuth for native applications on mobile apps and so on, or OAuth for web-based applications like, yeah, maybe we want to do things differently in modern browsers and so on and so on. And if you want to implement OAuth today, if you have to start with this, you are absolutely screwed. That's what it means. Because there's like at least a dozen specifications that you have to go through, and you have the original spec, and you read that and you're like, okay, I have no idea what this thing said, but I'll try to figure it out. And then you read one of the other specs and it says like, oh, that thing from the original spec, yeah, that's deprecated. We don't do that anymore. It's like, oh, crap. So why did I learn about that? And that's what OAuth 2.1 is going to do. OAuth 2.1 is going to reconcile all of these different specs about OAuth, not all of them, but a lot of them, into a single specification. They're basically going to clean up the whole mess of specifications around OAuth. They take the original one, they keep the relevant parts, which is like this much out of the whole specification, and then they add the advice from the other specs into OAuth 2.1. That's essentially what the story is here. So I'm going to talk about OAuth. I'm probably going to be saying 2.0 because I've been used to doing that for like 5 years, day in, day out. But if you do OAuth 2.0 the right way, using best practices, using the things you should be doing, then you are doing OAuth 2.1. That's the main takeaway of this presentation. So if you've had enough, well, you can leave now. You know that you're doing good, and that's about it. Otherwise, I'm going to walk you through what OAuth actually does, what you're supposed to be doing, what changed since 2.0, and by the end, you should have like a pretty good overview of the best practices in 2.1. Not everything, because a couple of things are still optional, but they're now unified into a single spec. That's essentially the story for today. To do that, I'm going to start by painting the landscape a bit, because OAuth is super confusing. I know because I talk to developers about OAuth. I give 2-3 day trainings on OAuth, and OAuth is very confusing. Some people have no idea what they're doing when they're using OAuth, which is fully understandable. I remember the first time I looked at the spec, I actually still remember, I was like, what? What are clients and how are clients backend web applications and what the hell is going on here? And it took me a while to figure all of that out. But the thing I want to talk about first is OpenID Connect. Because to make things a little bit more complicated, we have like an authentication protocol built on top of OAuth, which is not an authentication protocol. So it's like, oh, sure, why not? So OIDC, here's a screenshot from something we all got to know really well, Zoom. So everybody has a Zoom account these days. And OIDC is basically the authentication part. You can sign in with the username and a password using the identity provider of Zoom, or you can use social login here, or your enterprise login if you pay them enough money as well. That is OpenID Connect. That uses OAuth under the hood. It's like OAuth as a protocol, as a mechanism, but it has a completely different purpose. If you want to put that in OAuth terminology, or in the correct terminology, you would have client applications like a front-end app, a mobile app, a back-end web app, whatever, relying on an authorization server or identity provider to ask who the user is. asking about user authentication, offloading user authentication. Recommended best practice, by the way, these days. You don't want to handle authentication yourself. Offload it to a separate service. That is essentially what OpenID Connect brings to the table. And we're not going to talk about OpenID Connect at all. Good. What are we going to talk about? We're going to talk about OAuth. And back to the Zoom example, OAuth is about accessing resources on behalf of a user. That's the main use case for OAuth. So in this case, Zoom is asking my permission to access my Google Calendar. That's OAuth. Because to do that, Zoom has to go to Google and be like, hey, Google, I would like to access this person's Google Calendar. I don't know who this person is on your end, but they will tell you, and Google will evaluate that request. And that's essentially OAuth. So Zoom is going to Google here. Google knows who I am because I'm logged into Google, of course. And Google asks me like, hey, dude, Zoom is trying to access your calendar with these permissions. Do you like that, yes or no? I can give my consent. And at that point, Zoom gets access to the Google Calendar APIs on my behalf. That's OAuth, delegated access on behalf of a user, main use case. There's a few others as well. I'll come to that in a second. So what does that mean for our image here? It means that the client now asks access to APIs. If you're going to read the spec, it's not going to be an API. It's going to be a resource server, which is the OAuth way of saying something hosting a resource, which in today's world is going to be an API. Most use cases have APIs as a resource. That's what we're doing. Once that request is approved, the client gets an access token, an OAuth access token. With that access token, they can go to the API to make a request. Like, hey, create an event in Philippe's Google Calendar, or in the user's Google Calendar. Zoom doesn't necessarily know that I'm Philippe, just that I'm a Google user. Create an event, please. And there's a third leg to this picture. The API kind of relies on the authorization server to make sense of that request, either explicitly by going there and asking, what the hell does this mean? Or by implicitly verifying a signature on a token and assuming that the token is valid and using that information. That is the picture of OAuth. If you look at this picture, we're mainly going to talk about this arrow right here. This is where the bulk of the meat is. The rest is fairly straightforward, fairly easy, as in send the token there, include it in the header and you're done. And verifying the token on the API side of things is OAuth-wise not that complicated. There's a couple of pitfalls. But the main complexity of OAuth lies in this flow here. That single arrow consists of like 10 or 12 steps to get that done. And that's what I want to talk about today. Yeah, that's me. The introduction mentioned all of that. So if you want to read more, there's a website. You can talk to me over dinner. And if you've been at Sec4dev for a while, you probably know who I am since I've been here since the beginning. So if you want to see less of me, give me a very bad review, and maybe they don't ask me back next time. I don't know. If you want more of this, then give me a good review, and maybe I'll be back next edition. All right, back to OAuth. OAuth is about user-delegated access. That's the main use case. Me as a user allowing an application, Zoom, to contact an API on my behalf, Google Calendar. However, OAuth also has another feature, and that other feature makes sense in the whole ecosystem that OAuth is. And that is allowing a client access to an API just as itself. I'm going to use a restaurant review application as my presentation app, my training app, Restaurate. I love good food, I love restaurants. I'm actually a chef as well, so why not use that as an example? My application, Restaurate, has an API, and one of the endpoints of that API allows a client to get statistics of the number of reviews. So the client wants to make a call to get a count of the number of reviews per restaurant for that day, so they can display that on a website somewhere like, oh, we had, I don't know, 17 new reviews across 15 restaurants in the last day, because everybody here has to eat something at night. That's essentially what's happening. This is not on behalf of a user. There's no access on behalf of a user. This is not something user-related. It's just a normal API call. But we also don't want to expose that publicly. Like, we want to know which client is calling that endpoint, so we need some form of authentication. All right. That service is the OAuth client application. All right. What do we do first? Well, one of the first steps you ever have to do in OAuth to make something happen is register the client with the authorization server. So let's make, you're at the front, so you're the victim here. Let's make you the developer of that service. I'm the Restrograde admin. You come to me like, hey, Philippe, I have this cool client. Can I call your API? And I'm going to register your client in my dashboard, in my authorization server, and give you the necessary information. That's the process that's going to happen. If you have an open system like Google, you just go to the Google Developer Portal. As you would go to the Google Developer Portal, enter the information, and Google is like, here you go. But for me, it's a manual process. I'm not Google. I just do it by hand, by clicking around in the dashboard of the authorization server. And when I register a client, you get a client identifier right here. OAuth is heavily based on client IDs, which is some form of identifying this client later on. In this case, it's a screenshot from Auth0 because I'm an ambassador, so why not? And this is a randomly generated number or string, randomly generated string, but that's the ID for your service trying to access the APIs. And we also get a client secret, which you're probably not supposed to post in screenshots on PowerPoint presentations, but that client secret is what you would use to authenticate as your client application. We'll get to that in a second. All right, that's step number 1, client registration. Step number 2 is the API is also known. My Restrograde API is registered. This is usually just with some identifier, maybe some permissions. I'm going to skip over that. Those details are not too important. All right, so what do we do next? Well, your client wants to access, we have agreed on this, we signed a contract, maybe you paid me for that or I paid you, depends on the business model here. But your client wants to access that API, so it goes to the authorization server and it's like, hey, authorization server, I am this client, and here's a secret to prove that it's really me, because I'm the only client that knows that secret. And that's the call there. Authorization server will verify that and give an access token as a response. And with that access token, you can now call the API, and the API can verify that. That is what we call the client credentials grant in OAuth. This client credentials grant is used in various cases, but it offers a client access as itself. What's the main benefit here? That API doesn't have to know about different clients per se. It doesn't have to know how to authenticate clients. It doesn't really care about all of that. Imagine a world without this. Now the API would have like 10 different API keys for 10 different clients. It's like, no, let's not do that. This service is responsible for authenticating the client. This service just handles tokens issued by that service. So the API trusts the authorization server, and the only thing it needs to know is check the access token, maybe check permissions associated with that token, and allow the client access to this endpoint. That's it. Awesome. That is step number 1. If you want to see the details, we are developers, so monospace fonts make you warm and fuzzy inside. So this is a call to the token endpoint. This is the client calling the authorization server. It indicates it's running the client credentials grant. It provides a client ID, a client secret, and an optional audience, just so you know a bit of the details behind the scenes. All right. Takeaway number 1, the client credentials grant enables M2M access. This is a part of OAuth 2.0. I'll spoil things for you. It's the only flow from the original spec, from the one from 10 years ago, that has survived. This one is still good. I mean, we had 2 steps. We kind of managed to get that one right, so that's awesome. Well, the other people that wrote the spec, I'm not involved in that in any way. So no, I'm making fun here, but this is a flow that's still relevant today, still used quite a lot these days. That's awesome, right? But what if there's a user involved? Let me keep track of time here. What if there's a user involved? Because if I run late, the organizers are going to be really pissed at me for holding the bus and missing the dinner and stuff like that. So that'll teach them to push my talk to the end of the day. But no, I'm just messing with you. All right, so what if we have a user-specific case? Like, what if you want to allow a review scheduling tool to act on your behalf? Right? I mean, you look like an influencer. So what if you... Sorry about that. What if you want to schedule reviews to post them at the best time, like 5:30, 6 o'clock, when people actually want to look for restaurants? That would be awesome, right? So we have a tool that can do that. It's a backend web application, and you can log into the application, connect your Restrograde account, allowing that application to act on your behalf on the API. Meaning, you say, post this at 5:15 tonight, and the backend application is going to go to the API. It's going to post that review in your name. Just like Zoom would go to my Google Calendar in my name and do God knows what. I denied that request, by the way. I said, like, no way, after I took the screenshot, and that's it. Not that there's much in my calendar that you care about, but sure. So now the backend application is the OAuth 2 client application. Again, we register that, so let's make you the developer of the application. You have to come to me, we agree on a deal, I register your application in my portal, I give you the information that you need. You can set up the app and you can use the app. Awesome. One of the things you have to do when you register an app, not his app, the machine-to-machine app, there's no URLs involved. I mean, it's very easy, straightforward. But a web-facing application, you have a redirect URI. Because at some point, you're going to have to receive something through a redirect, and you specify upfront where to send that. Otherwise, an attacker could start a flow and say, when you're done, send stuff to evil.com, and I'll take it from there. That's not supposed to happen. So security hinges on that redirect URI or a callback. So you tell me, like, hey, register this callback URI. I'm going to accept the information at that endpoint. So schedule.restaugrate.com/callback. And you provide that here. And the authorization server now knows that that is a legitimate callback URL. Awesome. In the original spec, this was pretty chill. It's like, yeah, partial matching is fine, or maybe use some wildcards, or we don't really care, whatever. In OAuth 2.1, they said, like, yeah, let's not do that. So OAuth 2.1, that's a difference here, says like only exact URI matching is allowed here. No more wildcards, no more partial matching, no more any subdomain is valid. Exactly what you want. You can have multiple callbacks if you want to, but exactly that URI, nothing else. So that's a change here. So if you're doing OAuth 2.1, you must follow this requirement. All right. So let's run a flow now. The user of the application is going to indicate, I want this application to have access to my Restaugrate, or to Restaugrate on my behalf, just like I said in Zoom, connect to my Google Calendar. So the flow is going to start at the backend. So the backend knows like, oh, you want to do that? Awesome. Let's run an OAuth flow by sending you, or your browser, here in step 2, sending your browser to the authorization server. That's a redirect. And that redirect, or that request looks like this. So the request basically says, hey, we want to receive an authorization code. In response, you don't have to remember the dirty details here, but we're this client, so the client ID is in there as well. And when you're done, you can send the result back here. That redirect URI, that callback. Awesome. So browser is like, ooh, a redirect, I'm going to follow that. And the browser follows that redirect. Maybe the browser has cookies. If the browser has cookies, well, it depends on which browser, because some browsers are like, I have them, but you're not getting them. But that's a different story. I'm not going to talk about that. But if you have a cookie here, the browser will send that along. That's how Google knew who I was. When I clicked the button in Zoom, I didn't have to log into my Google account, but the browser sent my cookie, and Google was like, ah, Philippe, welcome back. Do you want Zoom to have access to your calendar? If there's no cookie, then the authorization server will ask you to log in. It's like, who are you? And you log in with your Restaugrate account on this authorization server. And you're like, yeah. And it's going to ask, like, do you want this application to have that access on your behalf? And you give consent. Awesome. When that is done, the authorization server returns an authorization code, a temporary artifact that can be exchanged for more useful values. That's why we call this the authorization code flow, by the way. All right. That redirect goes to that callback URI that you had to register up front. So you told me, when you're done, send it here. You told me in step 2, again, when you're done, send it here. I checked like, oh yeah, that's the value that you gave me up front, so I'm going to send it there. And you will receive that authorization code on your backend. Awesome. What can you do with that? Not much. It's a one-time code. That means nothing. It's a random piece of junk for you. The only thing you can do with that is go back to the, sorry, it looks like this. Details. The authorization code, you can go back to the authorization server and be like, hey, I got this code on this endpoint. What does that mean? By the way, I'm this client with this client ID and secret, and that's client authentication in step 7. All right. The authorization server is going to check all that, look up the authorization code, be like, oh, it's for her account, and yes, consent and all of that. So I'm going to give you an access token in return. That's the request going out, authorization code. Well, I have items here. Authorization code, the client ID, the client secret is supposed to be in here, my bad. There's supposed to be a client secret. That's a mistake on the slides. You can see that in the line numbering. 6 disappeared for some reason. So editing error. You would think I've had enough time to review the slides, but apparently I didn't. So the redirect URI is there as well, and that authorization code that you received. All right. Response is an access token, potentially a refresh token in this case, and with that access token you can access the API and post a review. All right, that is the authorization code flow. This is the authorization code flow that was originally part of the OAuth spec. And OAuth 2.1 says that every authorization code flow today has to use PKCE, proof key for code exchange. Ah, of course. Seriously. If you read the OAuth specs the first time, you're like, what? The names make no sense at all. PKCE is a mechanism that originally came from the OAuth for native apps spec, where they said like, yeah, sometimes we cannot associate the start of the flow here with the exchange of the authorization code here. There are some tricky attacks that can cause some issues there. So what if we add something to the start of the flow that allows us to prove that we are the real client when we exchange the authorization code? That's what PKCE is. A way to ensure that the same instance of the client that starts the flow finishes the flow. Because you're using the application, but if I'm using the application as well, then guess what? There's two instances going on, two sessions with that client, and if they get mixed up, you're going to be in trouble. Not me, because I'm going to be the attacker here, so you're going to be in trouble. So what is PKCE? Well, the flow is actually the same, but the client application here at the bottom generates a random value that we call the code verifier. A random value. And you store that random value in the session of the user. You keep it there. And then you calculate the hash of the random value. A SHA-256 hash. And that hash is what you include in the first request that initializes the flow. That's basically like telling, haha, I know a secret, but I'm not telling you what it is. I'm just giving you something I calculated on the secret up front, so I can prove to you later that I knew it when I started the flow in step 4. That's what this means. Like, I have a secret, I'm telling you I have something, you don't know what it is, but you'll get that later. So we run the flow like before, that code challenge ends up on the authorization server, it stores that along with the authorization code, keeps track of that hash. That's what happens in step 7. Then we have the redirect, and the backend application receives that authorization code. Awesome. Now it exchanges that for tokens with client credentials. And at that point, at step 10, it also includes that secret from the beginning. It also includes the secret saying like, hey, you know, I told you that I had something before, and here's the hash. I gave you the hash of that. Now I'm giving you the secret. And the authorization server is like, yeah, we'll see about that. And it recalculates the hash of that secret, compares it to the hash stored from the beginning, from step 5. And if they're the same, then we're reasonably sure that we're dealing with the same application. And you get your tokens, and you can call the API, and everybody's happy. That's PKCE. It ties the initialization of the flow in step 4 together with the finalization of the flow in step 10. Because only the legitimate client can do that. This came from the mobile world, where you would have like one app starting the flow and a malicious app intercepting the flow and trying to exchange the code. But in that case, it wouldn't have the secret, and the authorization server would be like, yeah, go away. No tokens for you. That's the idea behind this. It's a really valuable mechanism. It also adds security in backend flows like this one. So OAuth 2.1 mandates adoption of PKCE, which is, by the way, super easy to do, because step 2 and 3, your libraries will do that for you. You use the SDK from your preferred authorization server, and guess what? It's going to do PKCE for you. Done. Awesome. Takeaway 2, that I think, I don't have counts here, so I don't know. A takeaway here, the authorization code grant enables access on behalf of a user. That's essentially what this does. You get an authorization code first, exchange that for tokens, and you can do whatever you need to do. Awesome. What about front-end applications? Front-end web apps? Well, front-end web apps, this is the flow for a backend web app. If you change that backend at the bottom to a front-end, like that, there's one small hiccup. These client credentials, you can't store them here. Well, you can. I mean, nobody's stopping you from doing that. But if you store your client ID and secret in a front-end app, guess what the first script kid is going to do? Right-click, inspect source. Ah, interesting. So you can't store a secret there. That makes no sense. You cannot do that at all. And the flow for front-end apps uses no secrets in that step. So this means that all the security in a front-end app hinges on that redirect URI. Because you're telling that authorization server in step 8, send me a value here. And if that ends up in the wrong hands, you're in trouble. That's why OAuth 2.1 says, like, yeah, that redirect URI has to be an exact match. No subdomains, no wildcards, well, no wildcard subdomains and so on. Exact match or nothing at all. This is really important. This has happened, for example, Microsoft has lost a subdomain. Whoops. A DNS pointer pointing to something unregistered. Somebody registers that property. All of a sudden, you control a subdomain on Outlook.com. And you can trick the authorization server, like, when you're done, just send it to that subdomain. And the attacker would intercept codes, and there would be a massive problem. That shouldn't be possible if you control that application the right way. That brings us to the takeaway here. All the authorization code flows in OAuth 2.1 use PXE, also for frontends. So every user-facing application uses the authorization code flow, at least if you talk to OAuth 2.1. There's like a third flow. They have the client credentials grant and then authorization code flow. There's another one that isn't part of the OAuth specs. It's like a separate spec and it isn't included here. It's called device flow. If you ever paired like Spotify on your Apple TV, it gives you like a code and then you can log into Spotify on your phone. That's an OAuth flow called the device flow or the device code flow. But it's not part of OAuth, it's a separate spec. And it's also not part of OAuth 2.1, it stays a separate spec. Just so you have the full picture. All right, so OAuth 2.0 had 4 flows. You had the client, I have to check, the authorization code grant. Grant is like the OAuth way of saying flow. You have the implicit grant, the resource owner password credentials grant, which is a mouthful. ROPC is the shorthand, and the client credentials grant. The first one is sort of still valid in 2.1, but you need to add PXE to it. The original flow does not have PXE. If you add PXE to your authorization code flow, that's a valid flow. That one is still okay to use. The implicit grant is deprecated. That's the one that front-end web apps used to use. It's an old thing. It has some issues. Don't use it anymore. It's no longer part of OAuth 2.1. The resource owner password credentials grant is like the batshit insane flow where the client, the app would just be like, just give me your Google username and password, I'll send it myself, which is like, what? No, of course not. It was there for some reasons. Apparently, adding a line in the spec that says, don't only use it for this reason, means to developers like, whatever, I'm going to use it anyway. So this one has already been deprecated for like ages. I've always known it as deprecated, by the way. So this one was out pretty quickly. And then the client credentials grant is still good. That one is still in 2.1. So this simplifies the landscape. These two were deprecated in like one of the specs I showed you in the beginning. So you read the first one, and then it's like the second one. The second spec says like, oh, but that one is no longer valid. OAuth 2.1 simplifies the landscape, which is good. Whew, what a wild ride. There's another flow, the refresh token flow. Refresh tokens, well, back to our review scheduling application. You are going to schedule a review. Well, when you travel to the US, it's going to be a different time. Well, let's take Hawaii, that's easier. I was there in June for a conference, which is awesome, by the way. They have a 12-hour time difference. So if you want to schedule a review at like 5 p.m. Hawaii time, it's going to be 5 o'clock in the morning here. And maybe the application, well, or if you want to schedule something for here, it's going to be 5 a.m. in Hawaii. So you don't want to be up and running awake to give you like tokens to the application and run a flow, which means the application, your application needs long-term access to an API. You also want to be able to schedule a review tonight and tomorrow and in a week. And that's what we do with a refresh token. Refresh token flows, well, the flow is not modified in 2.1, but refresh tokens are modified. Here's how the refresh token flow works. Also applicable to front ends, by the way. You have a access token and refresh token in the client. The access token expires in a relatively short time frame. In a front end, that should be like 5 to 10 minutes. After 10 minutes, the access token is no longer valid. Meaning, the front end has to go there like, yeah, I got a refresh token before, can I get a new access token, please? Authorization server will verify that, and if the refresh token is valid, you will get a new access token. And with that access token, you can contact the API, and everybody's happy, and we're good to go. The refresh token flow used to be for backend web applications only for apps that can authenticate as a client. Because, well, you can kind of guess that these are sensitive. Because if you lose them, oops, authentication on the database is important. Who knew? And somebody has those refresh tokens, they would be able to abuse them if they don't require client authentication. So your backend has to authenticate, which makes them less abusable or less vulnerable. But the front end has no secrets, so refresh tokens here are bearer tokens. Well, they enable short-lived access tokens, but refresh tokens are bearer tokens, meaning that the bearer of the token, the holder of the token, is considered to be authorized to use it. Meaning if you steal my token, well, you hold it now, so you can use it. That's it. And this is kind of a security risk. On mobile apps, this is not as bad as on web apps because web developers have the tendency to just load code from anywhere and hope it works out. And one of the limitations, one of the restrictions they added to refresh tokens is refresh token rotation. And refresh token rotation means that every time you use a refresh token, you get a new one. They effectively become one-time use only. That's something relatively new. It's one of the specs, but it's part of OAuth 2.1. What does that mean in practice? It means that the front end gets tokens, token set 1, AT1, and RT1. That's access token 1 and refresh token 1. And after 10 minutes, the access token is going to expire. The front end knows that. So after 9 minutes, it will ask a new refresh token, a new access token. It uses RT1, refresh token 1, to get token set 2. And when access token 2 expires, it uses refresh token 2 to get access token 3 and refresh token 3. And you can see where this is going, right? And then you use token 3 to get token set 4, and so on, until the refresh token chain expires as a whole in, like, say, 8 hours. Then it's done. And the only way to recover when a refresh token is expired is running the flow with the user present again, and then the whole dance starts again. That's refresh token rotation. What is the meaning of this? The meaning is that we can detect refresh token abuse. At least that's a theory. How does that work? Well, we need an evil bet. Thomas, you're the evil hacker here, of course. And you break into a front-end application with cross-site scripting or malicious dependencies or whatever, and you steal a refresh token at some point in time here. Attacker, that's Thomas, steals refresh token 2, and he uses refresh token. He's like, ha, I'm the bearer of the token, I can use it, bam. And he uses that to get access tokens and refresh tokens. Thomas is now you, as far as the API is concerned. It's like, ooh, I'm going to post some reviews, and oh, schnitzel restaurant, super awesome. And your followers are going to be like, what? And the whole thing goes, well, you know how that goes. Anyway, the attacker uses that. But the application in your browser doesn't know that Thomas stole it, otherwise it would have fixed the problem. So the application is like, ooh, it's time to get new tokens. So it's going to use the same token, RT2, and the authorization server sees that. It's like, hold on, I already saw that one. Why the hell would you use it twice? Somebody must have stolen it and used it. So it's going to kill the token chain. It's going to revoke, well, it's not going to give you new tokens, but it's also going to revoke refresh token 3. So next time Thomas is like, I'm going to use refresh token 3, the authorization server is like, no, you won't. Bye-bye. And you lose your access. That's the idea here. That's refresh token rotation. All right. Refresh token rotation is mandatory in OAuth 2.1 if you do not have sender-constrained refresh tokens, meaning bearer refresh tokens, the ones that don't require possession of a secret or a private key or whatever, they require refresh token rotation, which translates to typically mobile apps and front-end web apps use refresh token rotation. All right, we're close to the end here, so I'm going to add some opinion into the talk instead of just spec talk. I think refresh token rotation is a crap security measure. It's absolutely bullshit. Sorry for the language. Why? Because I used the wrong person here. Because if your attacker is a script kiddie, sorry Thomas, then they're going to be like, oh, I'm going to steal a refresh token and use it, and bam, the thing just blows up. And they posted 2 reviews in the name of the user, and oh yeah, that was fun. But if you have a smart attacker, Barbara, if you have a smart attacker, They can just watch the application until you close it, after which you won't refresh the token and then start using a refresh token. So there's all kinds of scenarios where you can bypass these mechanisms. And this is not in the spec. I've been talking to the spec authors for a long time now, and they're like, yeah, well, we don't really agree, but this is absolutely bullcrap. If you're building a security-sensitive application, security-sensitive as in dealing with sensitive data, handling sensitive information, contacting sensitive APIs, front-end only clients are virtually impossible to secure if you have a vulnerability there. If the attacker gets a foothold with cross-site scripting, which shouldn't happen in the first place but is going to happen anyway, that's the reality, then having a front-end only client with no authentication anywhere in the flow is really, really hard or impossible to secure. So the right pattern there is a backend for front-end, where you combine your front-end app with a small backend component that handles the OAuth token stuff, and then the front-end just asks that component, send an API request for me, and give me the result. It's kind of a glorified authorization or authentication proxy service kind of thing. It's very lightweight. I don't have time to talk about that, otherwise they're going to kill me. But or cut my mic, that's more effective probably, so please don't kill me. But I'll happily talk to you about that over dinner on the bus, or you can search my website. I have talked about this before, and I'm going to be talking about this a lot more in the future. Keep in mind, front-ends only are really hard to secure if you assume that there might be a cross-site scripting vulnerability. All right, that brings us to this slide, beyond OAuth 2.1. Like you're all fired up and it's like, oh yeah, I want to punish myself by reading the OAuth specs. So what do you do next? Well, OAuth 2.1 was supposed to be compatible with OAuth 2.0. And that's awesome because it means, like Thomas and Barbara, they raised their hand like, yeah, we're doing OAuth 2.1 because they're doing OAuth 2.0 according to current best practices. And if that is indeed true, then you are doing OAuth 2.1, which is totally a draft, by the way. So everything I'm saying is outdated by tomorrow or something. But no, they're finishing up the language. The ideas are going to be fairly stable. But this also means that they can't pull in other best practices like, oh, you should also be doing this because, well, it's not a best practice for all OAuth 2.0 applications. So it's like, yeah, we can't really include this and we shouldn't include that. So that's a limitation. What does that mean? It means if you want to know more, you should start reading about resource indicators, jar, par, rar, and the FAPI2 profile. Which, of course, you're going to say like, oh, sure. No, resource indicators is a Finnish spec. It allows you to easily access multiple APIs by requesting an access token for each API. Instead of one token with all the authority, you'll get tokens for each individual API, which is a much better security model. So that's one thing. Sorry. Jar secures the authorization request. Like the URL with all the parameters, attackers can tamper with that. With jar, we sign it in a JOT. So the attacker, once the URL leaves the client, can no longer mess with the parameters. Par sends it directly to the authorization server because sending JOTs in URLs is a very bad idea if the URL is very, very long. So that's pushed authorization requests. RAR is about rich authorization requests. That's very fine-grained consent. For example, instead of asking, can I access your Google Calendar? The consent could be, can I get permission to add an event on Tuesday at 2 o'clock in the afternoon? That would be a fine-grained consent request. And then finally, FAPI2 used to be the financial API profile, like OAuth for really sensitive applications. Last time I heard, they were thinking about, because it's used in other places as well, to call it the fortified API because they had the abbreviation and they were stuck with financial. So it's basically a high security configuration of OAuth. That's where they say like, okay, this is what OAuth offers. You know what? This crap, like secrets that you can post on like screenshots, like out. We use private key authentication, and this is out, and this should be better, and we use this configuration there, and this requirement, and this. So that's what you would use if you use high security sensitive OAuth applications. All right, 4 minutes, including for the conclusion and questions. We can do that. Key takeaways. If you're doing OAuth 2.0 the right way, you're using OAuth 2.1. If you're not using OAuth 2.1, fix your OAuth 2.0 implementations or deployments. That's takeaway number 1. Number 2, user-facing applications use the authorization code flow with Pixie. Unless you're building stuff for like input constrained devices like Apple TVs, then the device flow is also fine. No implicit flow, no ROPC flow, authorization code with Pixie. And then third takeaway, if you're building a security-sensitive application, don't believe what the spec says about refresh token rotation or other anti-XSS security measures. Use a backend for front-end. That's what the real sensitive applications are doing, and that works really well. Thank you very much. No, sorry. If you want to learn more about OAuth 2.1, and like I added the 2.0 and I added 2.1, I have an online course about that. So if any of this is like, what the hell are you talking about? There's a free introduction course, like an introduction to OAuth and OIDC, because I believe everyone should understand these things just enough so you know, like, yeah, let's not touch that. That's also a good option. So follow the free course and follow the rest if you like it as well. That's not free. And thank you very much for being here, for staying out so long. Stick around for the questions, and then you can run to the bus for dinner, and hopefully we'll have a fun evening. Thank you. Sorry.
Thank you very much, Philippe. This was great. Really great talk. And we have some questions in Slido for you. I will start with the first one. Do you have experienced problems with using the rich authorization requests extension of OAuth? How usable is it in practice?
Honest answer, I haven't used it myself, so I don't know. One of the reasons I haven't used it is because it's typically a custom implementation. As in, the spec gives you all gives you the framework, like all the building blocks, and it's like, you have specific requirements, here's how you can build that, go ahead and work it out. But I haven't run into a scenario where I had to implement that, and I haven't found the time to play around with that myself. So honestly, whoever asked that, I have no experience, so I don't know about technical difficulties either. My apologies.
So what's the easiest way to implement OAuth into my application? Are there best practices for implementing?
Yes, don't. No, seriously. Don't implement OAuth. Absolutely don't do that. Use a library. I'm an Auth0 ambassador. One of the things that Auth0 does really well, there's things they don't do very well, I'll talk about that over dinner, but one of the things they do well is SDKs. They built front-end SDKs for Angular, and they actually modified their SDK to do things the Angular way, as in you can include a service and a component, and it's pretty and it works. Now for React, they have an SDK that does things the React way, and they have one for Vue, following the Vue options API and so on. I'm not a Vue guy, so I don't know. But they do things the right way, and they make it so that you can integrate that with 0 lines of actual code. You import the library, you give it like 2 configuration values, and bam, done. I used to talk about all these nitty-gritty details, like this value has to be that, and you have to check it like this, and now it's like, use this library, here's how you configure it, done. Awesome. So that's my answer. Use a decent library. There's also non-vendor specific ones. There's one for Angular by a fellow Austrian, Manfred Steyer. He built Angular OAuth OIDC. There's backend libraries for Node.js that are vendor agnostic, that work for any implementation. There's plenty of options available.
So, and one last question. Do you know GNAP, formerly known as OAuth 3? And if yes, what's your opinion on it?
I know of GNAP. Yeah, it doesn't sound very good, but GNAP, G-N-A-P, the Grant Negotiation and Authorization Protocol, if I'm not mistaken. It's going to be the successor of OAuth. Somewhere down the line, it's in active development. I know, well, I talk to developers, so there's no real point in me talking about fictional protocols. So I know that they're working on that, and I know that they're taking like a best practice approach from lessons learned. Like, hey, we kind of screwed this up with OAuth, so let's fix it from the start. But I don't have any practical experience. I honestly never even read the full spec, as in, I know what's going on vaguely, but I focus on things that we actually use today instead of things that we will use in 2 to 3 years at least, if not longer.
Thank you so much. So as you said, we have 45 minutes in the bus for questions. And
awesome.
Then 35 minutes, and then the whole dinner. And yeah, thanks again for you that you're here every year at sec4dev. We're really enjoying having you, and also for you a little present. So
wow.
Thank with me again, Philippe.
Awesome.